Okay. If we know the exact angle of the triangle, we can use our calculators to find the ratio in decimal form. So how am I going to do that? Sine of 60 degrees. So getting familiar with my calculator, I'm going to hit the button, sine, and then I'm going to hit the button 6, 0, and then the button equals. So sine 60 equals 0.866. And it goes on, but again, I don't need to write too many. I'm going to keep 3 decimal places, or if I was using it, I would keep it in my calculator because it has all the decimal places, even the ones that go off the calculator. So tangent of 36 degrees, tan 36 equals 0.726 and on. Right? It goes on a long way. So I wouldn't approximate. I don't want to write this massive decimal. Cosine at 82, so I hit cos 82 equals 0.139, yada, 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 yada. So again, these, a lot of them, certain ones are nice numbers, but a lot of them go on forever. So we want to be careful with what we're doing. So they're useful to find the length of a missing side of a right angle triangle. So let's see, if there's the corner, let's think about what we were talking. So there's our 90. Across from the 90 is our hypotenuse. I'm going to label that so that I know. That's one that I'm going to use. From my angle on the other side of the triangle, that is my O, my other side. And I'm not going to circle it yet. And then from my angle to the 90 is my adjacent side. And I'm not going to do that yet. So I've labeled everything. I have an angle. I have one side. I don't know the other. So I think back to my primary trig ratios. So, ka, toa. And I look. I've got an H. I need to find an A. So I have an H. I need to find an A. Oh, so ka, toa. So I'm going to use cosine. So I write cosine of the actual angle, 32 degrees, is going to be adjacent, which in this case is x, divided by hypotenuse, 15. Now cosine of 32 is a repeating number. I'm not going to write that in. Remember, that's just a number. So that's like 5 equals x divided by 15. To find out x, I'm going to multiply the right by 15, which means I multiply the left by 15. So what does that look like? That looks like 15 times cosine of 32 degrees is going to equal x. I'm going to do all of that in the calculator all at once. So I'm going to go 15 cosine 32, hit equals, and there it is. And let's now round to 2 decimal places, 12.72. And if there's a unit, I can say the unit, and there's the side. So let's do it again, color coordinated. Here's my 90, so there's my hypotenuse. This is the angle I'm looking at, or I'm given, 40. So on the other side of the triangle is my opposite side, and then from 40 to 90 is my adjacent side. I have adjacent, I'm trying to find opposite. There's my hypotenuse. I'll label it, but I'm not going to circle it because I don't want to use it. O and A, SOHCAHTOA, SOHCAHTOA. Okay, so this time I'm going to use tan. So again, I write tan of the actual angle in the corner I was looking at is going to equal SOHCAHTOA, x over 13. Rearrange to solve for the unknown, times 13, times 13. I would now have my answer. I could enter that in the calculator. I'm just going to rewrite it so that you can see 13 times tan of 40 degrees. When I enter that in the calculator, 13 tan 40 is 10.908. So 10.91. Again, if we had units, we add them. Excellent. So that works great if the unknown is on top of a fraction. What happens if it's on the bottom of a fraction? I hope. Well, let's see the next one. Maybe that will help us. Again, there's the corner we're looking at. Across from the 90 is our hypotenuse. On the other side, from our angle that we're looking at, is our opposite. And from our angle to the 90 is our adjacent. So what do we have? Well, we have an opposite and we're trying to find a hypotenuse. So we have one side, an angle, we're trying to find another side. Okay, so O and H, SOHCAHTOA. Sine. Okay, let's use sine. Sine of 39 degrees is going to equal, O, 8 over x. Okay, our unknown is on the bottom. We want to bring it on top. We can't just flip one side if we don't flip the other. Math is fair. Whatever we do, we're going to do both sides. We're going to do the whole equation. So let's just consider for a second. If we multiply the right side by x, we should multiply the left side by x. That means we have x times sine 39 degrees, which is just a number. Pretend it was 4, so we have x times 4, or 4x equals 8. So x times sine 39 equals 8. So the next thing we're going to do is we're going to divide by that number to isolate our variable, which means on the right we're going to divide by sine 39 degrees. So what that looks like then is x, our unknown, is going to equal 8 divided by sine 39 degrees. And on a good scientific calculator, I can put that straight in. 8 divided by sine 39 degrees, I hit equals, 12.712. I'm going to round right away. 12.71, whatever the unit would be. Last example together, and then I want you to try some. Here's the corner. Label the sides. Need to find adjacent. We have the opposite. SOHCAHTOA, SOHCAHTOA. Okay, we're going to use tan, TOA. Tan of 20 degrees equals O. So the value of the opposite side over A, the unknown of the adjacent side. So if we think about when it was on the bottom, it switched spots with the top of the left, right? They switched spots. So for load bearing and showing your work, set up or rearrange and then enter that in your calculator for one final answer. 10 divided by tan 20 is 27.4747419. Round it to 27.47. Done. There's your marks that I'm looking for. Set up, rearrange, solve. Set up, rearrange, solve. 3 marks, 3 steps. Give it a try.